Hello and welcome to Data Science for Everyone. Today we're going to explore Seaborn, an extremely important plotting library in Python. I will be taking the object-oriented approach while demonstrating Seaborn. Before watching this video, I highly recommend watching the matplotlib video. The link is in the description. Let's get started. Seaborn is a powerful visualization library that simplifies the process of creating attractive and informative statistical graphics. Built on top of matplotlib and designed to work seamlessly with pandas, it allows for easy customization and quick generation of complex plots, making data exploration more intuitive and efficient for analysts and scientists. In today's comprehensive guide, I'll teach you the basics of Seaborn using an object-oriented approach. Then I'll go into more complex visualizations and explore relationships between variables, whether quantitative or categorical. In the end, I'll provide you with tips and tricks on how you can customize plots to generate clearer, more effective communication of data insights. Let's start with the basics of plotting in Seaborn. For this demonstration, we'll be using the penguins dataset that contains different characteristics of 3 different species of penguins. We load the dataset using pandas read CSV function and store it in the penguins_raw variable. This data might have missing values that might interfere with our visualizations. To that end, we will remove those observations using the drop_na method and save the new data frame as penguins. Now let's see how to make a count plot. First, we'll import matplotlib.pyplot and Seaborn as plt and sns respectively. We set the data parameter to a data frame which is penguins, and we set the x parameter to the species column in the dataset. After calling plot.show, we get a clean count plot showing the counts of each penguin species. From the plot, we can see that the most common penguin species is the Adelie penguins. Also, notice that Seaborn automatically uses the column name as x-axis label since we are plotting directly from the data frame. Now let's see how to make a scatterplot. Here's the code that generates the plot. On x-axis, we have the body mass of penguins in grams, and on y-axis, we have the flipper length in millimeters. From the plot, we can see a clear trend. Penguins with larger body mass tend to have larger flipper lengths. But what if we want to know which points represent which species of penguins? Seaborn makes it super easy to do. To show which data point represent the different penguin species, we use the hue parameter. Just set hue equals to species, the name of the column in our data frame. Seaborn will automatically color each point based on the penguin species. It also adds a legend to the plot automatically, so viewers can easily tell which color represents which group. And if you're not using pandas, no problem. You can pass a list of values to the hue parameter instead of a column name. The hue parameter also gives us more control over how the values are displayed. For example, you can use the hue_order parameter to manually set the order of the categories in the plot. Just pass in a list of values in the order you want them to appear. In this case, setting the hue order makes the legend show chinstrap species before Adelie and Gentoo species. This is a great way to customize the plot to match the story you want to tell. You can control the colors used for each value by using the palette parameter. This parameter takes a dictionary, which is a data structure made up of key and value pairs. In this case, the keys are the values from the species column, and the values are the colors you want to assign to each one. For example, we can create a dictionary called colors that maps Adelie to black, Gentoo to red, and chinstrap to green colors. Then we set the hue equals to species and palette equals to the colors. Seaborn then automatically creates a scatterplot where Adelie penguins are shown with black dots, Gentoo penguins are shown with red dots, and chinstrap penguins are shown with green dots. This gives you full control over the visual style of your plot. Instead of color names, we can also use HTML codes. Just make sure there's a pound or hash sign in front of the codes and they're within quotes. One last thing to note is that the hue parameter works for most of Seaborn's plot types. For example, in this count plot, we are showing the number of observations for male and female penguins. By setting hue equals to 6, Seaborn splits each bar into subgroups, males and females, and colors them automatically. A quick detour before I move on. Looking at the YouTube data, I can see that only 9.3% of you have subscribed. If you have enjoyed the video and learned something new, please consider liking this video and subscribing. In data science, many questions focus on understanding the relationship between two quantitative variables. Seaborn refers to plots that help visualize these relationships as relational plots. These plots are especially useful when you want to explore how one numeric variable changes in relation to another. Relational plots are made using the relplot method. We call relplot and set the x and y axis to body mass and flipper length respectively. To make a scatterplot, we set the kind argument to scatter. This plot shown here is identical to the scatterplot we have shown before, but with relplots we can do much more. One big advantage of relplot is that it easily allows us to create subplots within a single figure, something that is much harder to do with scatterplot alone. Because of this flexibility, we'll be using relplots instead of scatterplot for the rest of the course. By the way, we can change the plot dimensions by setting the height and aspect arguments. I'll talk about plot customizations later in the video. To create subplot by different penguin sex, we can set the call argument to 6. This creates a separate scatterplot for male and female penguins, arranged horizontally in columns. By setting row equals to 6, we create a different scatterplot for males and females, but this time they're arranged vertically in rows. You can use both call and row parameters at the same time with relplot. In this example, we set row equals to 6 to create separate rows for 6 and call equals to island to create separate columns for individual islands. This gives us a subplot for each combination of these two categories, making it easy to compare patterns across different groups. As another example, let's look at subgroups based on the different islands. In this case, we have 3 subplots, one for each island, which can be a lot to fit into a single row. We can change the layout by using the call_wrap parameter. This lets us specify how many subplots we want per row. For instance, setting the call wrap equals to 2 will arrange the subplots into 2 columns, wrapping the rest onto the next row. We can also set the order of the different islands using the call order argument. We make a list of islands where we set the order and then set that list as the value of the call order argument. This organizes the islands based on the list order. Now that we have a basic understanding of relplots, let's get into more customization options. The first customization we'll look at is point size. In this example, we are creating a scatterplot of the body mass versus the flipper length. We want each point to reflect the bill length for each penguin. So larger bill lengths will appear as larger points on the plot. To do this, we set the size parameter equal to the bill length variable from our dataset. This kind of variation works best when the variable is either a quantitative variable like number of people or a categorical variable that represents different levels such as small, medium, and large. However, this plot is a bit hard to read right now because all the points are of the same color. We can make the plot easier to read by combining size parameter with the hue parameter. To do this, we set hue equals to bill length, the same variable we used for point size. Since size is a quantitative variable, Seaborn automatically uses shades of the same color instead of assigning different colors to each value, like it does with categorical variables. Now, penguins with larger bills are represented by points that are both bigger and darker, which adds contrast and makes the plot much easier to interpret. The next customization we'll look at is point style. You can use the style parameter to change the shape of the points based on a variable in your dataset. In this scatterplot, which we have seen before, we are already using hue equals to 6 to color the points based on penguin sex. Now, by also setting style equals to sex, Seaborn will use different point styles for males and females. This adds another layer of distinction, making it even easier to tell the groups apart, not just by color, but by shape as well. The last customization we'll look at is transparency. You can control this by using the alpha parameter. It takes a value between 0 and 1, where 0 means the points are completely transparent and 1 means they are fully opaque. In this example, we have set alpha equals to 0.5. This makes the points partially see-through, which is especially helpful when many points overlap. By adjusting transparency, you can better see where points are densely clustered or more spread out, making the plot easier to interpret. For our next demonstration, we'll be using the sales dataset that contains the revenues of 4 products in different continents. We will import this data as sales using the pandas read CSV function. By the way, all these datasets are linked in the description below. We can use relplot method to generate line plots. By specifying kind equals to line, we can create a line plot and more easily see how revenue for products change with time. Notice that relplot automatically colors each product and generates a legend. By setting the style argument to product, we can change the line style, which makes the visualization even more effective. There is another argument called markers. By setting markers to true, the plot displays individual points for each data. If you want, you can turn off the line style by setting dashes argument to false. When a line plot includes multiple observations for each x value, Seaborn automatically aggregates them into a single summary measure. To demonstrate, let's bring in the sales 2 dataset that has multiple observations per product per month. Let's use Boolean subsetting to filter out product A sales data and store it in a variable called A. As I earlier pointed out, when a line plot includes multiple observations for each value of x, Seaborn will automatically aggregate them into a single summary measure. By default, it shows the mean. You'll also notice a shaded region around the line. This is the confidence interval that Seaborn calculates automatically. In this example, we're looking at monthly revenues for product A. The confidence intervals are shown as a shaded region. Instead of showing a confidence interval, we might want to visualize how spread out the sales revenue for product A are. To do this, we can set the error bar argument to SD. This tells Seaborn to display standard deviation as the shaded area around the line. This is useful when you want to understand the distribution and consistency of data rather than just the average. To turn off the confidence interval, we can set the error bar argument to none. Now let's look at visualizations that has categorical variables. For these demonstrations, we go back to the penguins dataset. For categorical data, we'll use the catplot method. This is similar to the countplot method except more powerful and customizable. In this example, we call catplot and set the kind argument to count. This gives us the same plot as before, but with added flexibility of catplot, such as easily creating subplots. We can change the order of the categories as well. To do this, create a list of category values in the order you want them to appear. Then pass the list to the order parameter. This works not just for countplots, but for all types of categorical plots in Seaborn. Bar plots may look similar to countplots, but they show something different. Instead of counting observations, they display the mean of a quantitative variable for each category. In this example, we are using penguins dataset to show the average body mass per penguin species. To create this bar plot, we can use catplot and set x to species, y to body mass, and kind to bar to specify that we want a bar plot. Notice that Seaborn automatically shows the 95% confidence interval for these means. From the plot, we can see that the average body mass is higher for Gen 2 penguins. We can change the confidence interval as well by changing the value of the error bar argument. Here, we have set the error bar argument to SD, which shows the standard deviation. By setting the error bar argument to none, we can remove the confidence intervals entirely. We can change the plot orientation simply by interchanging the X and Y arguments. Just like other plots made with Seaborn, we can set the hue argument to change the color by individual categories. In this case, we set the hue to species. The plot now displays different colors for each species. Now let's move on to another type of visualization called boxplot. A boxplot is a great way to show the distribution of numerical data. The colored boxes highlight the range from the 25th to the 75th percentile, and the line inside the box marks the median. The whiskers extending from the box show how spread out the rest of the data is, while any points outside of the whiskers are considered outliers. Boxplots are especially useful for comparing how a numerical variable varies across different categories. Now let's see how to create a boxplot using Seaborn. Although Seaborn has a boxplot method, we'll use the catplot method instead, like we did earlier, because it makes it easy to create subplots using the call and row parameters. In this example, we'll place the categorical variable species on the x-axis and the numerical variable body mass on the y-axis. Since we want boxplot, we'll set the kind equals to box. And that's it. We have created a boxplot. Next, we'll explore different ways to customize this plot. Just like other plots, catplot lets you control the order of categories using the order parameter. In this example, we have created a list of species in the order we like. We set the order by passing the list to the order argument. Sometimes you want to remove the outliers from your boxplot. You can do this by using the showFlyers argument. Just set showFlyers equals to false and the outliers will be completely removed from the plot. By default, the whiskers in a boxplot extend to 1.5 times the interquartile range or IQR. The IQR is a range between the 25th and the 75th percentile of the data. If you want to change how the whiskers are defined, you can use the whiz argument. There are a few different ways to customize it. To extend the whiskers to 2 times the IQR instead of 1.5 times, set the whiz argument to 2. To define the whiskers using specific percentiles, pass a list of lower and upper values. For example, whiz equals to 5 and 95 will draw the whiskers at the 5th and 95th percentiles as I've demonstrated here. So far, we have explored several kinds of categorical plots like countplots, bar plots, and box plots. Now let's look at one final type of plot called point plots. Here's the code that creates the point plot. Since it's a categorical plot, we'll use the catplot method and set the kind argument to point. Sometimes we might want to remove the lines that connect the points in a point plot, especially if you're interested in comparing values within each category, not across them. To do so, simply set the line style argument to none. Let's explore a few ways to customize point plots. By default, the points and confidence intervals are based on the mean. But if you want to use median instead, you can do that by importing the median function from numpy library and setting the estimator parameter to median. Why might you want to choose median over mean? That's because the median is more robust to outliers. So if your dataset contains a lot of extreme values, the median can give you a more accurate picture of the typical value. You can also customize how the error bars are displayed in the point plot. To add caps to the ends of the error bars, use the cap size argument and set it to the width you want. In this example, we have set cap size to 0.1 to add small caps to the end of the error bars. Finally, just like with line plots and bar plots, you can turn off the error bars in a point plot by setting the error bar parameter to none. So far, we have learned how to create a variety of different plot types. Now, let's shift our focus to customizing them. Seaborn plots look great by default, but there are plenty of reasons why you might want to adjust their appearance. Customizing the style of a plot can reflect personal preference, improve readability, or help your audience quickly grasp the main takeaway. This is a plot we have seen before. It's a box plot of the penguin's body mass by species. We can change how the plot looks by setting the style using the setStyle method. The default style is called white, which features clean axis and a solid white background. This style works well when we are more interested in comparing groups rather than focusing on exact values. If we change the style to dark grid, a darker grid appears in the background of the plot. There are other preset themes available that you can check out in the Seaborn's online documentation. You can change the color scheme of your plot by using Seaborn's set palette method. Seaborn offers a variety of built-in color palettes that you can reference by name, or you can create your own custom palette to match your style or branding. Let's take a look at an example. We can use the built-in pastel palette to color our plot as I've demonstrated here. Here's a plot with another preset palette called Hustle. You can create and use your own palette as well. To do so, you can start by creating a list containing color names and passing it as an argument to the setPalette method. Instead of color names, you can use HTML hex codes as well. Here we have created a new palette with hex codes. Make sure that there is a pound or a hash sign before each code. Finally, you can change the scale of your plot by using the setContext method. The scale options from smallest to largest are paper, notebook, doc, and poster. Let's look at some examples. The default context is paper. I have demonstrated the rest of the styles here. We create data visualizations to communicate information, and that's hard to do without a clear title and informative axis labels. Let's look at how we can add them to our visualizations. Before we dive into how we can add titles, it's important to understand a key concept in Seaborn. Seaborn's plotting functions can return two different types of objects, axis and facet grid. Knowing which one you're working with will help you apply customizations correctly. To check the object type, first assign the plot to a variable. In this case, we store it in the plot variable. Then we use the type function to see what kind of object it is. Methods like scatterplot and countplot generate single-axis objects, shown in the left, and methods like relplot and catplot make facet grid objects. This information is used to add titles to the plot. Let's look at an example. To add a title to axis objects, we'll use the setTitle method as demonstrated here. By default, the figure title might appear a bit too low on the plot. To adjust its position, you can use the Y parameter when setting the title. By default, the value of the Y parameter is 1. So increasing it slightly, for example to 1.05, will raise the title a bit higher, making it more visually balanced. On the other hand, to add a title to the facet grid objects, we'll use the subtitle method. Similar to setting the title, we can use the Y argument to move the title up or down. To change the titles of individual subplots, we use the setTitles method. If you want to include the variable name in each title, you can use curly braces to reference it by using the call name in curly brackets. In this case, we have customized the subplot titles to display the penguin sex. To add axis labels to our plot, first assign the plot to a variable. Then use the set method to specify the labels. Set the X label and Y label parameters to define the X and Y axis labels respectively. This method works for both facet grid and axis objects. We can rotate the tick labels as well. After creating the plot, use matplotlib's xtick method and set the rotation parameter to whatever you want. I have set it here to 90. This approach works for both facet grid and axis objects. That brings us to an end of the video of how to generate plots using Seaborn. If you have liked this video, please subscribe to my channel. I plan to bring new videos every week. Also, please like the video if you have learned from it and comment on what else you want me to cover. Thank you and happy coding.